In this video, I am going to finish up the examples using stacks and postfix, and we're going to convert an infix operation to postfix. So I'm going to use a pretty standard algorithm for doing this. The algorithm is well known, and I am going to show you some examples first. We'll check out to see how this algorithm works, and then we will then go through the algorithm in Python. Okay, so just a reminder, some examples. If you have 5 plus 2, when you convert this to postfix, it's 5 2 plus. With parentheses, we have parentheses 5 plus 2 times 3. That's 5 2 plus, then the 3 and the star. Without parentheses, 5 plus 2 times 3 becomes 5 2 3 star times. Now, well, let's do one more example. 5 plus 2 times 3 plus 6 times 7 is 5 2 3 star. So this multiply the 2 times the 3, multiply the 6 times the 7, and then add, oh, I need another plus sign here, and then add those results together. I want to make a few observations about this conversion. First, I want to notice that there are some things that change order. So for example, this plus sign and this time sign change order. They change order because this time sign has a higher order of precedence than the plus sign does. And with parentheses, once we encounter the right parentheses, we want to group all those things inside the parentheses together. And with postfix notation, the way you group things together is you put operations after them. And the last thing I want to notice is that the numbers never change order. So the 5, then a 2, 5, then a 2, 5, 2, 3, 5, 2, 3, and so on. So the numbers in the postfix expression are in the same order as the infix. What might change order is the operators. Alright, so now we're going to go look at an the sample code we have from Python. And close this out. Probably should have saved that. Oh well. Okay. So here are a bunch of examples that I'm going to run when we get done going over the code. And here is the code. This is called the shunting yard algorithm. It was invented, well, it's discovered by Dijkstra. It was actually discovered previous to Dijkstra, but Dijkstra is the one that's known for this algorithm. Alright, so we're going to have an expression S. It's going to be an infix expression, and as in the previous video, that's going to be separated by spaces so that I can split it and get a nice array. And for the Dijkstra algorithm, we need 2 stacks. So stack overflow.py is where I've implemented a stack based on a linked list. So I'm creating 2 stacks, the output stack and the operator stack. The output stack is the stack that's going to eventually have the correct postfix expression in it, and the operator stack is a stack that's going to temporarily store the operations in them, because occasionally I'm going to need to reverse the order of those operations. And I'm going to reverse the order of the operations based on an order of precedence. So I also have a dictionary here that has the operations I'm working with, plus, minus, times, and division, and an order of those operands. So multiplication and division get a higher order of precedence. They are labeled 1. Alright, so tokens is going to be the original infix expression split on a space. And we are going to go through token by token. And here's how the shunting yard algorithm works. So if the token is a left parentheses, we just push it onto the token list. I'm sorry. We push it onto the operator stack. If the token is a right parentheses, that means that everything in between the left and the right was grouped together, and we now want to put them into a postfix expression. So we are going to start popping operators off this operator stack. So we do a pop. This is the previous operator. And then we're going to keep doing that until we get to the left parentheses. So as we encounter operators in the token that's an operator, we push those onto the stack, and in this case we're going to start popping them off the stack. So we keep popping until we come to the left parens, and when we pop an operator, we push it onto the output stack. And now I am wishing I hadn't gotten rid of that. Hang on a second. Now we'll see an example of this when I'm done talking, so we'll try to get this all covered here at the end. So just bear with me for a while. Alright, so we're pushing operators onto the operator stack until we encounter a right parenthesis, and then we pop those all off and push them onto the output stack. Okay, so this is all if we encounter a right parenthesis. If the token is not an operator, in other words it's a number, then we just push that onto the output stack. And now the last possibility we have in an infix expression, so we've covered a parenthesis, we've covered a number, we've covered a parenthesis again. The other possibility is that we have an actual operator, a plus, a times, divides, subtracts. Alright, so in this case, if the token is an operator, we need to see if we're following the order of precedence or not. So we're going to pop the previous operator off from the stack. We're going to check to see if that operator is none. If there's no operators on the stack, this will be none. We're going to check to see if it's a left parenthesis. And if it's none of those things, then we check the precedence of the token that we're currently at versus the precedence of the previous operator that was on the stack. And if the current token has a smaller order of precedence than the previous operator, then we push the previous operator onto the output stack. And then we keep doing that. So we keep pushing these higher order of precedence operators than on the output stack until we run out. And then once we're done, if the previous operator is still not none, that means we've encountered an operator that has the same order of precedence or as a left parens on a stack, and we need to put that back onto the stack. When we do a pop, we've taken it off the stack, we need to put it back. And then after we've popped all of the operators of higher precedence off from the stack, we take the current token and put that on the stack. Alright. Woo. When we're all done, there still will be an operator left on the stack, so we pop that off. There could be an operator left on the stack, so we pop that off, and if there is an operator, in other words if the operator is not none, then we push it onto the output stack. And I'm sorry, there still could be operators left on the stack when we're done on the operator stack, more than one. So as long as there's operators on the stack, then we pop them off the operator stack and we push them onto the output. Whoa. Alright, so let's run this and see if we can figure out how this is working here. We're going to get a lot of output because I've got prints in the middle of this thing. Okay. So the first one. So what we're going to get here is, this is the original expression. There's a for loop that takes us through all the tokens in this expression. So this for loop is going to do 2 plus and 3. And then I'm going to show you the operator stack and the output stack after we've done all this work here. So after we've done all these else ifs and else ifs and all that, here's where I'm printing those things. So this is the current status of those stacks at the end of the for loop. Alright, so 2 plus 3. The first token is 2, and since that's a number, it goes on the output stack. The next token is a plus sign, and since that's an operator, that goes on the operator stack. The next token is a 3, and since that is a number, that goes on the output stack. And then we run out of tokens. And then when we run out of tokens, so for token and tokens, we're done with that for loop. When we run out of tokens, then we come down to the operators, this while loop, and this goes through all the operators on the output on the operator stack, and that means there's one thing on the operator stack, the plus sign. It pops it from the operator stack and pushes it onto the output stack, and we get 2, 3 plus, which is the correct postfix notation for 2 plus 3. Okay, next one is 2 plus 3 times 5. So we're doing a for loop, and our tokens are going to be the 2, the plus, the 3, the times, and the 5. When a token is 2, that's a number that goes on the output stack. The next token is a plus. That is an operator, so that goes on to the operator stack. Then the next token is going to be a 3. That's a number. It'll go on the output stack. So now the output stack is 2, 3, and the operator stack is a plus. Okay, the next token is a time sign. So we are now in this complicated part of this for loop. So we're doing for token and token, and this is the case where the token is an operator, but this token has a higher order of precedence than the previous one. So it's a time sign, which has a higher order of precedence than a plus sign, so it just gets pushed onto the operator stack. Now, the last token is a 5, which is a number, so it gets pushed onto the output stack. And here's why we use stacks. So in the postfix notation, we've got this plus and this times, but what we really want to do is we want to have the 3 times the 5 and then add the 2. So these tokens are reversed, and that's what stacks do. Notice that we pushed the plus and the times onto the stack in this order, but when you pop, you take the last thing off from the stack. So basically what stacks do is they reverse things. And so now that we've ran out of tokens, we've got to the 5. Remember, this while loop just goes through the operator stack and starts popping stuff off and pushing it onto the output stack. So we'll pop the time sign, and that will go on to the output stack, and then we'll pop the plus sign, and that goes on to the output stack, and we get 2, 3, 5 times plus, which is exactly what we want. Let's take a look at one with parentheses. So we want to add the 2 and the 3 first, and then we will multiply by 5. Alright, so the first token is a parentheses that goes on the operator stack. Then the next token is a 2, that's a number, goes on the output stack. Then we get the plus sign, another operator, and notice that when we get to operators, right, we go into this part of the loop. This is the operator part of the loop. So we pop the previous operator, so that becomes the parentheses. And then we check, is the previous operator a left parentheses? Well, yes it is. So we didn't actually want to pop that left parentheses off yet. So this part of the while loop never executes. We check to see if it's a left parentheses. If it does, we don't do anything here for previous operator. So now we check, is previous operator none? Nope, it's a left parentheses. So we push that back onto the stack. So the left parentheses goes right back where it was, and then we push the token, which was the plus sign. So the effect here of popping this previous operator and then pushing the previous operator back on is if we didn't want to pop that previous operator, then it just goes back in the order that we I guess it intended. Okay, next token after the plus sign is a 3. Number goes on the output stack. Now our next token is going to be a right parentheses. So remember what happens with a right parentheses. When we get to a right parentheses, we're going to pop stuff off the stack and push it onto the output stack until we get to a left parentheses. So at this point, we've got a parentheses and a plus on there. We pop the plus, that goes on here. Then we pop the left parentheses. We don't do parentheses in postfix, so when we pop the left parentheses, then we're done. And that does not get pushed. Okay, so now where are we? We have a time sign. That's the next operator. That is an operator. It goes onto the operator stack. Then the 5 is the last token. It's a number. That goes onto the output stack. At this point, we're out of tokens. So we go into this while loop, which pops the remaining operators off, and we're left with 2 plus 3 times 5. Okay, maybe we'll go through one more example. Let me see how many examples we got down here. Well, we got this nice complicated example here. Let's go through. Let's see. This is a lower order. Yeah, let's go through this one. So we're going to go to the last one. Alright, first token's a parentheses, goes on the operator stack. Then a 5, it goes on the output stack. Then we have a division sign. Division sign goes on to the operator stack. Then we have a 2, that's a number, it goes on the output stack. And then here something interesting is going to happen. Something a little bit different. The next token is a plus sign, which is an operator. But for postfix, these operators are out of order. So let's come up here to this loop again. So the token is an operator. We're going to pop the previous operator, which is a division symbol. And that division symbol has a higher order precedence than the current plus sign. So that gets pushed onto the output stack. Then the plus sign gets pushed onto the operator stack. So we'll remove higher order precedence operators off this operator stack before we push the plus sign on. So if there had been a multiplication sign, a division sign, if there had been like 3 of those, they all get popped. They all go into the output stack because they're higher order precedence. Alright, so now we're at the 1. That goes on the output stack. It's a number. Then we're going to get a right parentheses. And the right parentheses, remember, is going to start. We're going to start popping stuff off from the operator stack until we get to the left parentheses. So it's going to pop the plus sign off and put that on the output stack. And the reason why we do that is because these things should all be grouped together now, right? Because they're inside of parentheses. So this is how you group things together in postfix. You end them with an operator. Okay, now we're going to start grouping again. So we've got 2 left parentheses coming up. So those are both going to go on to the stack. Oh, and we also had this multiplication operator in between. Sorry. That goes onto the stack as an operator. Alright, so now we've got multiplication in 2 parens. Then we're going to put the 2 on there. We're going to come to the plus sign. And we're going to check the previous, when we get to a plus sign, when we get to an operator, we check the previous operator on the stack, but that's a left parenthesis, so that doesn't have precedence over plus. So that's just going to stay on the stack, so we put the plus sign on the stack. Then the 3. Then we come to a right parentheses, so now we're going to put the plus sign onto the output and remove the first left paren. Then we're going to get to a time sign. The time sign gets compared with the left parentheses that's already on the stack. And since it's a left parentheses, we just put the time sign onto the stack. There's no need to swap anything around. Then we come to finally, well, we got the 3 goes over here. And we finally come to the right parentheses. That right paren is going to take this time sign and this left parenthesis off, remember we start popping things until we get to the next left parentheses. So the stack has a star, a times, left parens, and star, and we start popping once we encounter right parens. We pop off the stack until we get to left parens. That leaves us with a single time sign. We're out of tokens, so this last while loop again, we'll start popping tokens off until we run out, and pop that star off and put them on there. And that is the correct postfix expression for this infix expression. So, Dijkstra's algorithm. One of the things to keep in mind from this video is a use for stack is to reverse the order in which things appear. Alright, well, hope that was interesting. And in our next video, we're going to learn about trees.